let's do the next thing. I think you should be able to hear me now. Yeah, I'm not sure what happened to the audio. I can't be bothered, to be honest. But yeah, let's do this. Let's get to it. Okay. So I know we're not supposed to do this. What they are asking you to do this is in batch 3 segment intersection. So last time we did it with only one over here, right? And now we should be doing it with like many numbers. So for every segment, so for every day, we want to check if it works to every segment. Okay, that's the question here. For every day, right? They'll basically give you each day doesn't intersect with each segment. So let's look at the naive way of doing this, right? For so you do a dual for loop, or you do for they and days, for segment in segment, right? Does tensor dot append to else false. But I suppose that's not what they want us to do, right? Although this is what the naive approach is. What they want us to do is to use inobs.repeat to do this, right? So and both of their shapes become this. Let's look at this in a more interesting manner. Let's look at this in a more this thing. So what tips have they given us? Type checking. Personally, I don't care. I'm not using this thing. Use ellipses to do this. Element wise don't exactly work. I know that. We finished INOPS last few streams. That's okay. Then reductions, broadcasting, etc., etc. Okay, so this is what we want to do. This is the dumb way of doing it, right? What's this link text? I'm clicking on it. Oh, dead link, I guess. Let's check it now. So that's what's the idea behind it. The actual practice is no, I'm not sure what the actual practice is. It's let me send the link to people. Okay, so now now that they're at it, let's get to the thing. This is the hard part, right? The only hard question is how do we check the intersection of like every day with every segment, and this suggests doing this without a for loop. Let's think of it. Suppose I have one array and two segments, okay, just for my own ease of use. And how would I do it? For each day, I would have to go up and do this, right? For each day, I would have to. Well, I have one day only, so my dx and dy remain the same. But then But what they want us to do is not that. They want us to like have a 4-dimensional tensor. They want us to repeat it n segment times. Right? So you'll have a 4-dimensional tensor in both cases. So you will repeat this. You will repeat n ray n segment times. You'll put n segment n ray times, right? So let's do that. inops.repeat raise new equals inops.repeat. How do you do this? You want to repeat raise, right? It's pattern. So raise right now is n raise number count dimension. Return it. Well, we gotta do it this way. ls equals segments dot shape dot 0 dot item. Oh, it's all in integer. I see. Forgot how to. Let's inops. Okay, so we do. Gonna fail. It goes without saying it's gonna fail, right? But the question is, does it work? Do it hedge and put n. Sorry. Oh no. No. I want to repeat it n times, right? I want to have this. So we want it to be 9323. Right? Maybe I should be doing not this. Maybe I should be doing. You have to give me the inops repeat over here. Yeah, this works. Okay. Right. Now we have this, and we also have to do new segments equals inops.repeat segments, comma. Well, segments have number. They have a count, they have a dimension. Returns repeat number count dimension, comma. Repeat equals raise dot shape colon 0. Print new segments dot shape, comma is the new segments shape. Yeah, this works out. Okay, now what? Suppose I have it. I suppose I have it. Now what? Now what? Now what? How do you implement like batched matrix inversion? I'm not even sure how the math of this works, to be honest. That works from the plinth. Right. This just annoys the hell out of me. I will do it segments underscore new. Right. So. Huh. Okay. Okay. So we have this. How does that? I can do it in double for loop. Right? This is the dumb way of doing it. How do it for n of those? This how now it'd be cooked in some of these. They is 1 comma colon 2. Got this. This I get. Single theta. I see. Right. Okay. We're putting into a single theta tensor of 2 by. Got it. So then, okay, let's do this. I see what's going on here. So what you're doing is stacking it. I see what's going on. So now, stacked over here, I see. The solver can solve them parallelly. This is the meat of it, right? So what's going on here is that I gotta stack them, and I've done that. Amaze. Correct, I've done that correctly. Now I just need to find the correct matrix to solve. So what does GPT do in the previous ones? This is fully vectorized, right? Got that. That's right. All the direction vectors, all the segment vectors, all the start to origin vectors. Okay. Okay. What does this mean? If I have a 3D tensor, what does this mean in Torch? But why am I doing? I don't know what's going on here. I do these new. Correct. It's correct. Oh, okay, right. Oh, I see. So taking the D part of it, and we did that last time using Ray colon 1. Then what do we do over here? After we take the D, we find the L1, L2. So L1 equals segments, right? Every ray, every segment. Then we do what? Minus segments new, sorry. Is this correct? Correct, these are direction vectors. L1 0 now. Equals segment new colon this minus this new colon equals minus colon and then the first one should be 0, right? Colon 2. Correct. Waiting, waiting, waiting. It's correct. Okay, it's back on. Correct. So now we just gotta solve it, right? A equals T stack this. Do we have to subtract it? Why did they do the negation of it? We didn't do a negation last time. Stack it up, right? So we do A equals then B equals correct. Okay, I get this, right? Try x equals, what is this? Intersects. Can you explain this? Correct. T dot 0 is this. T dot. I'm definitely gonna hear about this. Oh, okay. Correct. Okay, let's see how it goes. Passes. Okay. Why is giving me a 403? Am I banned from less long? No way. Okay, so yeah, we're doing pretty well on this. Okay. Make race 2D. So we get some origins, right? We'll get 0, 0, 0 as our origins. I get that. So first we do for a number. Oh, it's times, not multiplied by. So we gotta do something. Oh, double for loop where. Yeah. So here we had a single for loop, and here we have a double for loop. And here we had a single for loop, right? For I in range, whatever. Okay. Now here we have a double for loop, but I'm not sure how to do it. So let's see how we can do it. So let's look at this, right? Num equals -1, step equals this. Okay. Let me just save my changes before I do something. No, we want to do finished one-dimensional. Now we can bag it back to it. After that we get a triangles, right? This is super cool. What's going on here? Then we have implement Raytrace triangle. Okay. And then we should be done here, right? Integer relations mesh. Okay, we're getting there. We're getting there. Y parts equals num pixels y minus 1. Z parts equals num pixels z minus 1. Step y equals 2 times y limit slash y parts. Step z equals 2 times z parts, so z limit right, and we start off, in range y num pixels y for I in range num pixels y. And what do we do here? We say intersect these one, sorry, not this, in segments. Indices times step. So yeah, so we get I times step y minus y limit, right? I times step y minus y limit, right? And then we say, hey, the x is again 0, right? Because we're going to start off at 0, 0, 0. So yeah, this is it. This is our y value. Last time we did something. Did we get our x values to be different or something? I forgot how this works. T dot ones, parts plus 1. T dot ones in number of pixels. Why are all the directions 1? I forgot. Oh, we assume x equals 1 in this, right? They say x must be equal to 1 in this also? Yes, x must be equal to 1 in this. For j in range num pixels j, num pixels z, z val equals j times step z minus z limit. Answer depend 1 comma y val comma z val. Answer should be a pytorch tensor, and I need to do this without a for loop. Huh. This is complicated. Perfect. Hmm. Mesh grid. I see. I see. We can use these then. We have to create these as well. We need a data argument, right? We don't need that. We don't need that. Oh, we forgot to turn this on. We're doing it second time, right? So, yeah, let's once again. And this, and this, and this, and this, and this. And this, and this. Oh, I think we had a mistake here. Okay.